Hello again everyone, welcome back to ptet.chemistry channel. So in this part 3 of a four video series on backward titration that is to do with mole calculation involving solutions, I'll cover more examples of how this type of questions could be asked in A-level and how they could be asked from practical perspective as well, because all of these are experimental data, and these questions have been derived from Jim Clark's fantastic book on calculations in AS and A-level chemistry, which if you don't have access to the book, that's alright, because you could practice with whatever I cover within to other examples you might have encountered from past year papers or from your curriculum textbooks or from whatever assignment your teacher might have given you. Alright, so yeah, moving on to this example really. So we want to find the concentration of some dilute hydrochloric acid. You can take 25 cm³ of it, you dilute it accurately to 250 cm³. So what do we have? We have 25.0 cm³ of the 25.0 cm³ of an acid of a HCl. Okay, so perhaps I can say the concentration is what you want to find. You want to find the original acid, yeah? So if I use a square bracket of that substance indicate that is the concentration. You will learn this eventually when you cover topic of Kc, which is to do with equilibrium concentration, but a square bracket of the substance indicate concentrations, which I'm telling you right now, okay, so that it makes more sense to you. All right, so you are going to dilute it to 250 cm³. And then what else? So here you are just having the mole is the same because you are just adding water, but the concentration is different because you are adding 10 times the volume of water. Okay, so the concentration is actually 10 times smaller, but the mole is the same. Okay, what else do we have here? We have a second reaction. Our second reaction is really sodium hydrogen carbonate. So in Jim Clark's book, they use quite a lot of, or he used quite a lot of sodium. He used quite a lot of this hydrogen carbonate anion. This is different from carbonate anion. So the formula you will get is NaHCl3, whereas here you get Na2CO3. So you need to be careful of how you get your formula correct, otherwise your equation might not be correct. Okay, so when you add up, not really, no. Okay, so that is not the reaction yet. We need to dissolve the sodium hydrogen carbonate. So that's 2.25 gram, and then you dissolve it in, well, you put it in a beaker first before you transfer it to the volumetric flask. There will be 250 cm³ of it. But in essence, what it means is in 250 cm³ you have this much 2.25 gram of sodium hydrogen carbonate. Okay, so from this 250 cm³ you take out 25 cm³. 25 cm³ for your titration. So here we know the mole is different, but the concentration is the same. The concentration is the same. Okay, when you take out 25 cm³, the concentration is the same, but the mole is different. Whereas here, when you do dilution, the mole is the same, but the concentration is different. But then you also take out the dilute hydrochloric acid, okay, but you only put it in the burette. That is how much you want to know, how much you want to use. So typically before, we've always just prepared out the exact volume, which is 25 cm³ into it, right? But here this is a different example where this one goes into the burette. That's why the volume that you get of the hydrochloric acid is not like a fixed volume like 25.0 cm³ or 10.0 cm³ or something. But does not matter. You need to think about what is what, yeah? So this is your hydrogen carbonate. This is your dilute HCl. So it has a concentration of HCl dilute. Alright, So we need a balanced equation. We really need a balanced equation. Sodium hydrogen carbonate plus HCl give you NaCl, the salt, Na plus Cl minus. You give you CO2 and you give you H2O. That equation is just balanced, just directly like that. I think part of the reason why Jim Clark used a lot of sodium hydrogen carbonate in his book is because the equation do balance out quite nicely and it's quite easy to see in earlier example. But he did move on to more complicated examples like calcium carbonate or sodium carbonate, which is actually the example in the next question. So you will progressively see harder and harder questions which you can expect at A-level calculations. All right. So what do we know? What do we know? We know that 25.0. So I need to find the concentration of the dilute acid first. I need this. From this, I can work out that. This is what is happening in the titration. Okay, so I would need the mole of the HCl over the mole of the NaHCl3. But I'll take note that is the HCl of the dilute solution, okay? So it's 1:1. The dilute solution of the HCl, I will need 25.6 cm cube of it. So 25.6 cm cube of the dilute acid. Convert to dm cube because all the top bit are for the HCl. So that is the concentration in square bracket of the HCl dilute. And then the concentration of the sodium hydrogen carbonate, which I am not given the concentration of the sodium hydrogen carbonate. So what should I do? Work out the concentration of the NaHCl3 in mole per dm cube. Well, you need the MR. You need the MR of the NaHCl3. So my periodic table show me is 23.0 times 1 plus 1.0 plus 12.0 plus 16.0 times 3. I get 84.0, which your calculator will show you as 84 only. So when now mole per dm cube is equal to gram per dm cube. Well, actually that does not matter. I'll show you what I mean. In order to get mole per dm cube concentration, I know the mass divided by 84.0, so that is mole. Mass over mR is mole. How much volume do I have? It is in 250 cm cube, so I convert that to dm cube, and then that will give me 2.25 divided by 84 divided by 250 times 10 to the minus 3. I get 0.1071 mole per dm cube. And I know that even though the mole are different, when I only use 25 cm cube, the concentration is the same because I am taking out from this solution which I just make up. So the concentration there is the same as the concentration there. Alright, so it's 0.1071. It's actually 2 mole decimal place, but instead of converting it to 3 sig fig based on the data, I still need it for further calculation, so I use slightly more than 3 sig fig. I use 4 sig fig there. 0.1071 is the concentration of the NaHCl3. 0.1071. So the volume I needed was 25.0 cm cube for the hydrogen carbonate. You see, 25.0 cm cube sample of this solution refer to the hydrogen carbonate. So 25.0 cm cube of the hydrogen carbonate multiplied by the correct concentration in mole per dm cube. That's going to give me the HCl dilute. As I hope you can move all of that up, but I'll just write all of it down so that you can see what I mean exactly. So the math in A-level is not that tricky. It's more about understanding the mole ratio and thinking about those things in a deeper sense. Yeah. So again, I don't run it up too early. So I get the concentration of the HCl dilute. But remember what is happening here? So I know the concentration of the HCl dilute now. Okay, so I know this thing because when I put this in the burette, the concentration of the dilute solution I put in the burette is the same as the concentration here. My job is, how do I find the concentration here? The mole is the same. the mole is the same in this 250 cm cube versus this 25 cm cube. So with that knowledge, so the mole of the HCl concentrated in 25 cm cube is the same as the mole of the HCl dilute in 250 cm cube. I want the concentration of the HCl in the concentrated solution, meaning in the original solution. That means it's original times 25. Maybe I should use original times 25.0 times 10 to the minus 3. I know the concentration in the dilute HCl, that is in 250 cm cube of solution that I make up. So I convert that into dm cube. Therefore, the HCl original is, well, you can hopefully tell that it's actually 10 times bigger. And you can see that the volume factor there actually give you 10 times bigger the concentration. There's 1.04. I don't want to write too far onto the right hand side, so I'll write there 1.0459. Now is the time to convert to 3 significant figure, because it's the final part of the answer, and also all the data in the question were to 3 significant figure as shown previously as well. Okay, so I hope that gives you an idea of dilution there. So moving on to the next question, which is sodium carbonate. So I talked earlier about getting the formula correct. So there's Na2CO3 there. Oh, they actually give you the formula there. Yeah, okay, never mind. What do I have? I have 2.86 gram of Na2CO3 dot X, not X, but dot NH2O. You make it up to 250 cm cube. So my diagram are always quite bad, but at least I know what I'm talking about. Yeah. From this thing, you take out 25.0 cm cube using pipette, I will assume. Yeah, here you go, pipette. And then you titrate it. Titrate it against HCl. How much HCl do you need? Well, you have the concentration, which is 0.100 mole dm cube HCl. You have 20.0 cm cube of acid is required. So I hope you can see that from here to here. So that is just dissolving in water. Your mole is the same. I cannot talk about concentration being the same because this is a solid and this is a solution, alright? But the mole is the same. Here, the concentration is the same, but the mole is different because you are taking out 25 cm cube from 250 cm cube. So it's a conversion factor of 10 again. Because the concentration is the same, your mole is going to be a factor of the smaller volume over the bigger volume. Okay, so I have a reaction here. This is your first reaction and your only reaction here, really. So HCl plus Na2CO3, because we are no longer dealing with what do I say? We are no longer dealing with hydrogen carbonate. Okay, when you dissolve this in water, okay, the water just dissociates into water. That's why in this reaction, it is not the 1.NH2O, it's just Na2CO3. Okay, I hope that makes sense to you. That will give you NaCl plus CO2 plus H2O. That's why I don't use the .NH2O there, because when you dissolve in water, this is all you have. Okay, it's the water dissociate into water already. Balance the equation because 2 sodium there, 2 chlorine, so I need 2 of the HCl. So now there's 2H, give me that 2H, 1 of the all go there, that will give me 1 CO2 there. Okay, so that is balance. Once I have the balance equation, what do I need? I need to find the mole of the sodium carbonate is to the mole of the HCl. So that will tell me that is 1 over 2 from the balance equation, right? And then I need the mole of the Na2CO3, because this is the Na2CO3 aqueous, Na2CO3 aqueous. Okay, so the mole of the Na2CO3 in 25.0 cm cube. So I want to find the mole, so I keep it as the mole. the mole of the HCl that reacts is 0.100 mole per dm cube times 20.0 times 10 to the power minus 3. The information given in the question of how much acid actually reacts. Alright, so therefore the mole of the Na2CO3 in 25.0 cm cube is half times 0.100 times 20.0 times 10 to the power minus 3. So that gives me 1 times 10 to the power minus 10 to the minus 3 mole. So what is this? This is the mole of Na2CO3 in here. I've shown it in this diagram, very poorly drawn diagram. Concentration is the same, but the mole is different. Okay, so our job really is to, therefore, the mole of Na2CO3 in the 250 cm cube solution is going to be however much the volume in 250 over 25 times the mole in the 25 cm cube. Hope you can see easily that since the concentration is the same, you have bigger volume, therefore you have more mole. You have bigger volume, therefore you have more mole by a factor of 10. That is 0.01 mole. That is the mole of the carbonate in here. But this is the Na2CO3 and H2O. So what is the mole of the Na2CO3 dot NH2O? Is going to be the same as the mole of the Na2CO3. Instead of writing that, I can show you that in a ratio form. Okay, there is 1/1. Why is that? When this dissociates in water, it will give you that in a 1:1 ratio. So quite straightforward there, yeah, quite straightforward. So what do I need to do now? So the mole of Na2CO3 dot NH2O is the same as the mole of Na2CO3 that I found previously in the 250 cm cube, because their mole is the same. So if I know the mole of the sodium carbonate here is the same as the mole of the sodium carbonate here, and the mole of sodium carbonate, it comes from that, so it has to be 1:1. Okay, in hindsight, this is probably a waste of time to write, but I just want to express to you, you can see 1 mole of that will give you 1 mole of that, yeah, where the water just dissociates. So that's 0.01 mole, which I carry forward from there, and from the diagram you could see above, yeah. So the mass of that thing above was 2.86 gram. Remember the whole thing here was the hydrated sodium carbonate with the NH2O. Okay, so that is the mole, that is the mass. What is the molar mass? The molar mass of sodium carbonate, I think I worked it out before. Did I? Oh no, before I work out the sodium hydrogen carbonate mass, which is different. Okay, so let's work it out. So 23.0 times 2 plus 12.0 plus 16.0 times 3. My periodic table shows me that it's 106.0. So it's 106.0. The MR of H2O was 18.0, so it's 18.0 multiplied by N. So I can bring up my bracket, so this will be 106. I'm just trying to be simplified now. That's 2.86. Expand your bracket carefully. You will get 1.06 plus 18 times 0.1, this is 0.18 N. So 0.18 N is equal to 2.86 minus 1.06. So N is equal to 1.8 divided by 0.18, and that gives you a very nice answer of 10 as the whole number. If you happen to get a decimal place, you should always round it up to whole number, because water crystallization is always a whole number in my experience. Okay, so this happened to be a perfect whole number, so you're nice and easy there. So this is the end of this particular tutorial video. So watch out for there should be a 4th video of this 4-video series on calculations involving solution chemistry. I try to cover examples that vary over the entire range of questions you might be asked at A-level. These have been exemplified from Jim Clark's book on calculations in AS and A-level chemistry. which if you don't have the access to, like I said, you can always just practice with calculation question from your curriculum textbook or your classroom assignment, and hopefully the strategy that I cover within and the clear method, systematic method that I show within will be of some help to you. So I'll see you in the next video, and if you haven't subscribed to the channel, please subscribe and share the channel with the rest of your friends and colleagues and students. Okay, thank you.